7.3, sketching slope fields. Okay, a slope field represents a differential equation on an xy plane. It shows the slope of all the particular solutions to the differential equation. Below is a differential equation with its accompanying slope field. So this is a differential equation because it's a derivative equal to something. Okay, the slope field represents all the slopes of all the possible points for the differential equation, the original equation y. We use a little, like a little tick mark to show the slope. So for example, let's look at this thing. If I was at the point 0, 0, I would plug in x equals 0 here, which would mean dy dx is equal to 0 there. So to show the slope at 0, 0 is 0, we make a little hash mark like that. Okay, if I went to 0, 1, 2 times 0 is still 0. Oh, 0, 1's actually up here. 0, 2 is up here, 0, 3. So that's why all of these have a little flat line, because the slope of all these little slashes is 0. And we're using that just to show it. Okay, let's try a couple other random points just to look. Okay, say we went to like 1, 1. At 1, 1, the x value is 1, so 2 times 1 would be 2, which is why this is a positive slope, and it does look like it could be 2. At negative 1, 1, 2 times negative 1 would give this a slope of negative 2. It looks like it could be negative 2. At negative 1, also negative 2, and at 1, negative 1 would be positive 2. So this is just representing, each of these little lines is representing the slope of a point to the original equation y. Okay, the slope field tells you the direction of all possible equations included in our little graph here. So what does that mean? Okay, let's imagine that the graph was passing through 0, 2. Okay, it passes through 0, 2. The slope there is 0. Okay, and then it goes this way. And the slope here is kind of positive. It goes up here and it's kind of steeper. On the left side, I can see the slope is positive, positive, positive. So these little marks are kind of showing you the way of the graph this way. Okay, this represents, this differential equation represents infinite numbers of actual functions. So say I went to x squared, not x squared minus 3, 0, negative 3. At 0, negative 3, the slope of the original function is 0. We go like this, and then it kind of curves up like this. And I'm just kind of following the slope field to see which way the graph would go. It would kind of go like this. I'm going to go up this way, like that. There's a bunch of other possibilities as well, but this is kind of what it would look like. Okay, let's just consider what y would equal by doing the antiderivative. So let me take the integral of both sides. If I do that, I get y equals integral of 2x, raise it to x squared, and then divide it by 2. 2x squared divided by 2 is just x squared. And let me add a constant. Okay, so the function that has this derivative is y equals x squared plus c, which looks right here, because if I did y equals x squared plus 2, it would look like this. If I did y equals x squared minus 3, it would look like this. If I had y equals x squared minus 1.5, it would probably look something like this. Okay, so the slope field is just showing us which direction it's moving in the slope at each of the individual points. Okay, let's go ahead and try to draw our own slope field. And it's going to be a sketch. Okay, it says use the differential equation to create a slope field. So for A, it's dy dx equals x times y. I'm going to look at each of the points that have a little dot there. Let's start with the easiest one. Let's start at 0, 0. 0, 0. If I plug in, if x is 0, y is 0, if I plug that in here, 0 times 0 is going to be 0. So the slope at 0, 0 is 0. So make a little flat line, horizontal. Okay, so I went to 0, 1. Well, 0 times 1 is still 0. Actually, everywhere x equals 0, dy dx is going to equal to 0, because 0 times anything is 0. So let's go to 0, 1, 0, 2, 0, negative 1, 0, negative 2. Okay, and actually, everywhere that y equals 0, dy dx will also equal to 0. So let's go to 1, 0, 2, 0, negative 1, 0, negative 2, 0. Let's continue. Let's go to another spot. How about 1, 1? At 1, 1, the slope is 1 times 1, which is 1. So I'm just going to draw a little hash mark that looks like it's has a positive slope. Maybe it's 1. It's just a guess. Or it's a reasonable estimate. If I go to negative 1, 1, it's negative 1 times 1, which is negative 1. So it's in the negative. Slope is negative. Negative 1 times negative 1 is positive 1. 1 times negative 1 is negative 1. So negative slope. Okay, let's go ahead and let's go to 1, 2. 1 times 2 is 2. So it's positive. It might be a little steeper. It's an estimate, so it's okay if it doesn't look that exact. Negative 1, 2 is going to be a slope of negative 2, so negative but a little steeper. Negative 1 times negative 2 is positive 2, positive but a little steeper. 1, negative 2 is negative 2, so negative slope but a little steeper than the previous. Okay, let's go out to where x is 2. So 2 times 1, 2, 1. Slope is 2. Okay, and then if I go to 2 times 2, 2 is 4, which is pretty steep. Okay, I'm going to go down to quadrant 4. 2 times negative 1 is negative 2. 2 times negative 2 is negative 4, which is pretty steep. Okay, in quadrant 2, negative 2 times 1, negative 2. Negative 2 times 2, negative 4. Quadrant 3, negative 2, negative 1, positive 2. Negative 2 times negative 2, positive 4. Okay, so this is a sketch of the slope field using this differential equation. Let's do one more. Okay, for b, dy dx equals y minus 2x. This one's a little harder to do in my head. And it's not that you have to show work, but you have to do a little more mental math. Okay, I'm gonna start with 0, 0 because it's easy and I'm lazy. Okay, so if I start with 0, 0, 0 minus 2 times 0 is 0. Great. Okay, let's go to 0, 1. Okay, if I went to 0, 1, that's going to be 1 minus 2 times 0, which is going to be 1. So let me make this slope 1. Okay, let's go to 0, 2. That's going to be 2 minus 2 times 0, which is just going to be 2. Okay, let me go to 0, negative 1. What's that? Negative 1 minus 2 times 0. Negative 1. 0, negative 2. Negative 2 minus 2 times 0, which is negative 2. So a little more steep. Okay, let's try another. How about when x is 1? When x is 1, let's try 1, 0. 0 minus 2, negative 2. How about 1, 1? 1 minus 2, negative 1. 1, 2. Y is 2, so 2 minus 2, that's 0. Let's try 1, negative 1. Negative 1 minus 2 is negative 3. 1, negative 2. Negative 2 minus 2 is negative 4, which is pretty steep. Okay, let me go to x is 2. 2, 0. What is that? 2, 0. That's going to be 0 minus 4. Steep. Negative and steep. How about 2, 1? That's going to be 1 minus 4. Negative 3. How about 2, 2? That's going to be 2 minus 4. Negative 2. 2, negative 1. Negative 1 minus 4. Negative 5. 2, negative 2. Negative 2 minus 4. Negative 6. Super steep. Okay, one last column. How about negative 1s? And you don't have to show work for all of them. You can do these in your head. Okay, negative 1, 0. 0 minus 2 times negative 0 plus 2. So we're going positive 2. That's 1 plus 2. 3. Negative 1, 2. That's going to be 2 plus 2. 4. Negative 1, negative 1. Negative 1 plus 2, 1. Negative 1, negative 2. Negative 2 plus 2, 0. Okay, so that's my slope field. when dy dx equals y minus 2x. Okay, let's look at example 2. Example 2, it says the figure below shows the slope field for the differential equation dy dx equals 1 minus xy. Let f be the function that satisfies the given differential equation. Write an equation for the tangent line to the curve y equals f of x through the point -1, -2. They just want a tangent line. Okay, so tangent line, what do I need? I need the slope. If I want the slope, I'm going to do the derivative. So let's do, it says y equals f of x. So let's use dy dx. dy dx. Oh, they gave me dy dx. It's right here. I don't even have to do any work. Okay, they want me to evaluate this at -1, -2. So that's going to be 1 minus -1 times -2. So what is that? 1 minus 2, -1. That's the slope of the tangent line. They gave me the point, so it's really just y plus 2 equals -1 times x plus 1. I answered the question. Did I need the slope field? No. Is it fun to have it? It's fun to have it. Let's look at it, even though we didn't really need it. Okay, where's -2, -1? Or sorry, -1, -2 is right here. Okay, the slope of the tangent line is -1. So this tangent line is going something like this, which it looks like it could match. Okay, I'm going to use the slope field to kind of just like guess what the graph's going to do. Not because it asked me to, just because it's fun. Okay, so let me follow this slope field. So it's kind of going like down, it's kind of going up, it's kind of going this way, and then it's doing weird stuff. I kind of think there might be an asymptote here or something. Okay, let me go this way. It goes kind of like this, kind of like this, kind of like this. Okay, just for fun, if I drew the tangent line here, it does look like the slope of that tangent line is -1, which matches what we were doing. We didn't need the slope field, but it's fun to have, so you can kind of imagine what the function was and then see if it kind of makes sense at the end. Okay, let's do one more example. It's multiple choice. Let's call this example 3. Okay, example 3. Below is a slope field. And we need to figure out which of these equations this matches. Is there a real good way to do this? No, let's just plug in some points. Let's pick some easy points to plug in or something where we can kind of read it really well. Okay, so let me see. 0, 0. Oh, there's not a mark at 0, 0. I would use 0, 0 if it was clearly labeled, but it's not. Let's try 1, 1, because I see something then. Okay, at 1, 1, I can see that it's going to be some kind of positive value. Let me see if that helps me narrow it down. Okay, so if I plug in 1 here, I get 1 plus 1, that's positive. 1 squared, positive. 1 plus 1, positive. 1 over 1, positive. The ln of 1, that is 0. Okay, so I've eliminated it. Now I'm down to 4 answers. Okay, let's look for another good point. How about -1, 1? That looks like it has a 0. I'm a fan of a 0. So that looks like the slope at -1, 1 is 0. Let's try -1, 1. Okay, so if I plug in, what was I plugging in? -1, 1. Okay, so 1 minus 1, that is 0. Okay, if I do -1 squared, that is not 0. -1 plus 1, that is 0. -1 divided by 1, that is not 0. Okay, now we're down to A and C. Okay, let's just find another good point. Let's try -1, -1. -1, -1 is down here. It's negative, so let's just see if I get a negative value. 1 plus -1, oh, that's 0. So I don't think it's A, but let me verify by plugging in C. -1 plus -1 is -2. So A didn't work, C is my answer, and I just used the process of elimination to find it, so the slope field was useful for that.